We can take your data and bring it to life, not in the Dr. Frankenstein type of way, but by adding movable animated elements to your favorite plots, we can tell our data stories in a powerful way. In this session, we'll discuss how you can implement data animations in my favorite plotting library, Matplotlib, as well as the newest data viz tool on the block, ipyvizzu. But first, we here at Don't Use This Code often assert that there are two types of data visualizations. Those that are exploratory in nature and those that are communicative. When it comes to telling or communicating messages with data visualizations, animations can be a powerful tool that allows you to create cohesive and narrative stories. We can embed context and seamlessly drill down or regroup in a way that is all too comprehensive and enables us to both reach a broader audience and even maintain their attention better. What can I say? People love it when things move on their screen. You've probably seen me write a lot of Matplotlib code, but I will be sharing with you some Matplotlib code in a way that might be a little bit unfamiliar. Instead of using the classic plt.show, I will actually be sharing all of my visualizations with you through a tool called Panel. This is one of those low-code dashboarding tools. I often use it when I want to share data visualizations that are not static, that allow people to interact with them, maybe with widgets, or even sharing non-data visualizations that allows me to embed things like Markdown or HTML. So let's go ahead and bring up my browser as well as the first visualization that we'll be discussing today. When we want to bring something to life, you often think, I'm going to make a PowerPoint. I'm going to make this PowerPoint and I'm going to slowly reveal to them elements of my data such that I create a narrative story around it. And this is the whole idea behind animations. Now, I hope you're thinking, Cameron, I really hope you don't put animations in your PowerPoints because that's kind of, early 90s-ish kind of feeling. So you have things fade in, fade out, or maybe they jump in from way off screen. But the easiest thing that we can do with a little bit of hand waving in Matplotlib is, well, I can actually incrementally build this plot for you. And already by revealing the title, you know exactly what this plot is going to be, sine and cosine functions. So I'll go ahead and I'll add my plot onto this page here. Then I can even go ahead and I can say, but maybe from this plot, I don't like the x-axis. When we're talking about trigonometric functions, we don't think of the x-axis in values of whole integers. We often think in units of pi. And I can go ahead and change that for you as well. Last but not least, I have no idea. I always forget, does sine start at 0? Does cosine start at 1 when x is 0? So of course, we need a legend to help us label each of these pieces. And one by one, I have built you a chart. Now, there's no story or cohesive narrative behind this chart, but I've built you a chart of individual pieces. And by doing this incrementally, I have actually guided your attention to attend to each one of these elements on this chart in a specific direction that I controlled. And this is the power that animations give to our data visualizations. You can control your audience's attention to force them almost to look at one element and then look at another. Whereas if I laid this chart out in front of you without layering each individual element, you would look at this, you'd maybe look at the title first and look at all the lines and then maybe the legend. You don't have that type of control when you want to tell a story. And when you tell a story, it is all about guiding every member of your audience down the exact same path so that they all come to the same conclusions, they all reach the same highs and lows, and they actually feel the data that you are sharing with them. And this is great. For Matplotlib, this is very easy to do. We can add these elements one by one, they pop in. But what we lose from popping in is the context. Where did these data come from? Where do each of these elements originate? And so, things get a little bit trickier when we want to actually add data to an existing Matplotlib figure. And so if we actually want to add data to our Matplotlib figure, well, we can make sort of a workaround here. I can actually go ahead and I can write a function that generates a plot for me. Then I can create another function that actually updates that plot. And instead of relying on Matplotlib's underlying mechanics, I can use my dashboarding tool here to essentially iterate over some number of frames, create that plot, and then just swap that HTML element out from under the plot so it really looks like my plot is changing. And then I can specify the number of chunks or the number of frames I want to divide this into. So if we take this from 0 to 6 pi, you see that this is my trigonometric functions here. But instead of maybe just one frame, I could divide this up into 50 frames, and you start to see this slowly transforming figure where I'm adding plots or adding data to an existing plot. Now this is all illusionary because I'm not actually just adding data to the plot. I am redrawing this plot, rendering that redrawing, and sending that HTML up to my panel application where it is then shown or displayed to you. Now, I hope you're thinking, this is great for a single example, but if you wanted this to scale, there's absolutely no way. This is all rendered server side, and if I have maybe widgets that control the X and Y axis, we're talking about hundreds, maybe even thousands of concurrent users who all want different variations of this plot. That's all that load is bearing server side. So maybe this doesn't scale super well. And the last part that I did want to share with you about this data visualization is that this is completely controlled by panel. What I'm doing here is I'm actually adding a periodic callback to my server and incrementing the state of my generator that actually creates this plot. And that gives us this illusion that we're actually adding data to a Matplotlib plot here. But there's a better way that we can do this within Matplotlib that we don't need to use actual server kind of workarounds. We can actually render an entire animation all in Matplotlib. And now I hope you are all familiar with those racing bar charts that have been all the rage for about the last 2 or 3 years. Well, we can actually create racing bar charts in Matplotlib. And what I want to share with you about the racing bar charts is they differ a good amount from their line chart counterparts, and they differ a good amount from just a static bar chart because you can actually show dynamic interactions. I'll go ahead and run this cell because some of these animations do take quite some time to render. Essentially, what we're doing here is I have data from the Olympics from the past few years. And before we get to the Olympic data, I actually wanted to share with you how we can transform these sinusoidal and cosine functions into a more seamless animation. By relying on Matplotlib's animation mechanics, we can actually create very smoothly interpolated plots. Now, before my previous plot where I was really just rendering this server side and sending this up to my panel application, you could see that there were very discrete kind of frame skips. And that's just because of the way that we were rendering it. If I use Matplotlib's internal animation mechanics, we can actually create a truly animated and very smooth looking plot. And Matplotlib has a very small API to do this, but it's a little bit mechanical. So I want to share with you some of those mechanical steps so that we can make sense of how Matplotlib draws and updates things. The very first thing of making any Matplotlib plot, of course, is creating my figure, my axes. Then I set my X and Y limits, my locators and formatters, things like that. But then you'll see a step that might not be as familiar. I'm actually creating a bunch of 2D lines in Matplotlib, and I'm assigning them no data. I give them, of course, labels and a line width, but there's no data underlying them. I then go ahead and I just feed this directly into Matplotlib's function animator. And what this does is it takes a figure, it takes some function that goes on and updates the artists on that figure, and it takes some idea of frames. And you can see here that my frames is actually just my data frame, and I'll show you my data frame just very quickly so you can see what this looks like. This is, of course, just my sine and cosine functions, and my x index here, right, are all of my multiples of pi, or all of my x values. And so when we're creating this animation, I can actually feed these frames as just a generator. The data frame.expanding gives you the first row, then it gives you the first 2 rows, first 3 rows, so on and so forth. And it all gets fed into this updating function. This takes my frame, so each iteration of my expanding data frame, this takes those lines, that artist that I created, the empty ones, as well as my axes. And you can see that I've actually partialed these attributes or these variables into this function here. What we then do is I'll then iterate over all of those lines. And remember that each of these lines are actually stored into a dictionary, right? That maps one line to each column of my data. Pretty straightforward. I then need to update the data underlying those lines. And the reason that we do this is because I don't want to create brand new lines every time I update my frame. I actually want to take the existing lines and I want to change the data that is underneath of those lines, that backs those lines. Because if I add new lines, all of a sudden, if we have, say, 200 frames in this animation, I'm creating 200 times 2, so 400 brand new line objects that Matplotlib has to keep track of. Not to mention, I'm also going to be triggering the property cycler in Matplotlib, and so I would actually be drawing different colored lines unless I manually control the color. And so what we actually want to do is we actually want to just update each of these lines independently, updating their data underneath, and then we actually return those lines so that Matplotlib knows under the hood what elements of my data visualization are actually going to be changed. And we want to have a little bit of manual control over our x limits here, or else our x-axis would not be expanding as we added data, and that would lead to a little bit of confusion. But you can see you actually get quite a nice data visualization out of this, or quite a nice animation, I should say. And this is, of course, then rendered into a video HTML5 tag, and then that is what I share up to my panel application. Since under the hood, all this is just a generator that calls a function on every tick of the generator, I can use my iteration helpers, things like iSlice. So maybe if I didn't want to start at the 0th frame, I could start at, say, the 20th frame. And this would allow me to kind of bootstrap my visualization here to maybe show the first 20 frames and then the last 80 frames. So the first 20 will pop up instantaneously. Another thing that we could do, and while that renders, another thing that we could do, and you can see there, we actually started at about 1.5 pi units on my x-axis and instead of starting at 0. Another thing that we could do is instead of simply updating the right-hand side of my x limits here, I can actually update both the left and the right hand side, and we actually get a very different streaming effect generated by this animation. Instead of having our data being added into our visualization and squishing everything to the left, we can have a visualization that scans across, or apparently scans across from left to right. And so there are many different things that we can do with these small little tricks in Matplotlib to animate. But this is good for, I'd say, streaming data, right? If you have maybe live data updates, you can use some of these tricks. But I honestly, if I had actual streaming data and I was streaming to a web dashboard, Matplotlib's probably not the thing that I would be reaching for, because you can see that I'm actually running these cells. It takes about 10 seconds for this animation to render into HTML and then serve that HTML up to my dashboard. But can we make something more complex? Can we make something that actually has a narrative to it, that actually uses a real-world data set, where we're not just using these artificial sinusoidal and cosine functions and just streaming data on top of them? Well, let's take a trip through history, I should say, and look at the Summer Olympic medals won over each Olympics by country. And so here we have a distinction to make. We can represent, if I have hundreds of countries, and I have hundreds of Olympics, or I should say number of Olympics, how can I represent these data? Probably the most obvious explanation, the most obvious intuition will say, well, you would put your years, right, the Olympics on the x-axis, and then you would put the total medals won on your y-axis, and then maybe we would use a channel like color to say differentiate each of the countries and then plot all of the countries, and maybe just plot a subset of those countries. And then we could use tricks like pop out, so we could just color maybe a few countries that we care about that we want to track. But you can think, if I plot hundreds of countries in different colors on the same chart, that would be incredibly noisy to look at. And this is what the racing bar chart idea helps us get over. And now the racing bar chart isn't only good at summarizing large amounts of data, it forces your audience to focus on each individual data point, right? Each year you can see the 1920 to 1924, 1928, so on and so forth. And this forces you to focus on how the positions change over time. We see that the United States has the most cumulative medals to date, but second place is Soviet Union. We can see how these switch. But what we failed to do with this format of a racing bar chart is we failed to really convey how those positions change over time. Now, what I've done here is I've, of course, loaded in my data. I have medal counts. I have a joining table of country acronyms to country names. And we take this same kind of approach that we saw above. I create a bunch of horizontal bars, and they all essentially have no underlying data to them. You can see here that the width is actually just 0 times the number of bars. But what we then do is we update the positions and we update the width of those bars. And you can see this takes the same exact format as what you saw above, and I partial my update positions function. We're just using that expanding as our frames. The frames takes any generator or any number even. I prefer using the generators because you can actually pass data into this function. But all we're doing here is we're just taking each of those bars and we're setting its Y position and we're setting its width. And for each tick of our frames, we're calculating, right, the current total number of medals won as well as the current ranking of each country. But what we're missing out on is actually an interpolation, right? If the United States were to become second and Soviet Union were to take first, or United Kingdom were to take first, we would actually, in this animation, I'll replay this video, things just change, right? They just pop all over the place, and you can't actually track, well, wait a minute, where was Italy in the frame before this one? They just kind of appeared out of nowhere. Did they come in off the bottom of the screen? Were they actually placed higher and they just dropped down? It's very hard to tell. And so, if we want to create an animation that's a little bit smoother in Matplotlib, we actually need to interpolate these frames on our own. And of course, this is going to require a lot of code, and it's going to require about 45 seconds to render this thing to HTML and actually serve it to my panel application. So we'll get this going now. But essentially, you can see that the code takes a very similar format to what we saw above, except I'm actually pre-calculating all of my medals, the total medals won at each year, each point in time by country, taking that cumulative sum, and I'm also taking my ranks, and then I'm concatenating these into a single data frame. So I have an index, right, of years. I have as many columns as I have countries. Multiply that by 2 because I have 2 separate data frames that are side by side. One is the total medals, number of medals won, and then the other is the current rank of that country. And so what I then need to do, I can't just take the number of years. I actually want to take the number of years and actually interpolate between my rows. So instead of just having 1896 to 1900 to 1904, I secretly want everything in between. And you can see how many steps I'm taking between. I actually want 10 steps in between to create an actual smooth transition between my bars. And so this has finally rendered, and you can see that I've actually created the illusion that these bars are slowly moving over time as our Olympics increase, and this really captures and really emphasizes how positions change over time. You can see that Hungary is 8th place right now, and that they keep gaining more and more medals. Oh, Hungary just got moved by Sweden, France, and the Soviet Union. And this lets you focus on each of these individual frames, each of these individual data points, one at a time, while also very strongly emphasizing the change over time, the change from frame to frame. This is what the racing bar chart does actually quite well, in my opinion. Although you lose the ability to look at the data from an all-encompassing perspective, we can drill down and we can emphasize each year over year, the year over year change. This is what you don't really draw your attention to in a line graph. If I were to look at these data with just a single line chart, I would probably look at the rightmost part, to where the cumulative total of today is, and I'd say, oh, cool, United States is in first, so on and so forth. And so in order to do this, we had to take a few extra steps. You can see I actually have a lot of code here that is not focused on the data visualization itself. It's actually focused on creating an animation and interpolating between the frames of that animation. This reindex and this interpolate is actually doing a ton of work for me under the hood. Then I write my own generator here to yield different parts of my data frame. And you can see that the update positions, this is a little bit more complex, but it's actually very much the same pattern that we saw before. But what if I say, you know what, maybe for making animations, Matplotlib can do it, but I don't want to worry about all of these different steps. I don't want to worry about manually interpolating things. Well, this is when we would reach for a tool like ipyvizzu. We can load in our data in the same exact way, and all we need to do is create our data specification, add our metals or our data to it, and then we create a series of configurations. These configurations are then serialized and passed to my front end. And so what this looks like is I'm actually declaring some channels, what my X and Y axis will be. And so my Y will actually be my country, and my X will actually be my total metals. And we're always going to sort by value, so we're always going to have the country with the most number of metals on top. I go and then instantiate my chart, and I add some animations to my chart. So I add my data, I add my styling, and I add my configuration while also setting a title. And so let's go ahead and take a look at what this chart looks like. Very quickly, I want to show you how I'm actually rendering this or showing this to you. This is just all rendered as an HTML element and served to our screen. And you can see the instantaneousness of it. The nice thing about this is that these animations are not composed server-side, so you're just composing what the frames will be by passing these configurations. These are all then rendered on the client side. And so let's go ahead and actually add an animation here. I'm going to filter down. There's so many countries here, and I'm just going to filter down to countries that have won more than 80 medals total. So by 2012, which is the most recent data point I have, we're going to look at the countries that just have 80 medals total. So let's go ahead and re-render our animation. We're going to show this for just a few seconds here. And then you can see we actually drill down into just a smaller subset of countries, and you can tell that the title changed. This kept the original position or the original ordering of our y-axis, so you can seamlessly see the transition from my entire encompassing view into this drill down. Now let's take these same countries and let's step through history a little bit. And instead of delaying for 5 seconds, I'm just going to delay for 1 second. And all the delay does is say, stay on the previous frame, right, the previous instance of my chart, just for however long, however many seconds. And so we'll just stay on that encompassing view for just a moment. We're going to drill down, and then we're going to start actually creating our race. And you can see here that these bars are actually they're moving, transitioning very smoothly. I can actually see the changes year over year. My title is continuously being updated, and we actually get a very nice racing bar chart here. And the amount of code that I had to worry about, all I had to consider was, what does the current frame look like? What does the next frame look like? I don't have to worry about interpolating anything by hand. That is all taken care of by ipyvizzu for me. Now, what if I want to explore these data just a little bit more? Maybe I don't want to look at the year-over-year change, but maybe I want to zoom in even more here. And I'll do that by zooming out. We'll zoom out first. And then what we're going to do is we're going to zoom back in, but we're just going to look at a few select countries here. So we'll go ahead, restart our visualization, or our animation, I should say. We're going to drill down. These are the countries that have won more than 80 medals overall. We're going to zoom back out, and then we're going to go ahead and zoom back in to just these 5 select countries here. Now, maybe I want to drill down to these countries for a reason. Maybe I want to redundantly encode on my color channel so that we can start conveying information about each of these select countries in colors. And I'll go ahead and we're going to drop out a few of these frames that are unneeded here. And so let's go ahead and get rid of that. We'll get rid of this zoom out here. We'll get rid of filtering down to 80. And we'll go ahead and display. We've now short-circuited our animation just to go straight into these 5 countries, and we'll get rid of this delay as well. Now we've added a layer onto our chart. We've actually color-coded these countries and as well as positionally separated them. And what we can do is we can actually attach, say, a year to our x-axis. So if I wanted to see this not as an individual horizontal bar chart, but maybe a splitted horizontal bar chart, this is what we can achieve with ipyvizzu. And so you can see the width of each of these bars is actually the number of metals won in a given year. So the bar on the furthest left-hand side, this is actually 1896, 1900, and so on and so forth. And so we have very fine-grained control over what we want to show our audience. Maybe we then want to drill down into another frame. We want to resort how we share these data. So let's go ahead and walk through our animation one more time here for our selected countries. And then we have our split horizontal bar chart. We can actually reorganize these data into a vertically stacked bar chart. And you can see, there's a lot of years here on my x-axis. I can almost not make out any of these individual years. So let's go ahead and drill down. And at the same time, it's very hard to compare each of these Olympics to each other because maybe there were more events, maybe there were less events, but the total number of medals given out at each of these Olympics is not the same. And so what we can go ahead and do is we can actually stretch our chart so it's percentage based instead of absolute count based. And lastly, we can actually examine just a subset of our years on our X range. So let's step through this animation. We have our selected countries, and then we have a transition into our stacked vertical bar chart or a stacked column chart. Then we stretch this to be percentage based, and now you can really see the United States wins most medals. Most often they're represented by the light green. And then we zoom in on just a subset of our data here from 1948 to 1988. And we can see that, well, even though the US won the most, the USSR, Soviet Union, actually performed quite well overall as well. And very interestingly, you can look at this single column here in 1980, and this is the Summer Olympics where the US did not participate in the Summer Olympics. And what we can do here is we can actually stitch together all of these frames very easily. Just need to uncomment this code, and we can look at the entire animation as a cohesive single story. And now there are a lot of different stories intermingled in here. I wanted to share with you the capabilities that ipyvizzu gives you that you can bring to your own data visualizations, because it's a very powerful tool that lets you communicate to the broadest audience possible. You don't really need to know anything about data visualization to make sense of this type of chart, because the transitions and the animations makes it so your points cannot be missed. I'm really taking my story and putting it in your face. And so here again, we have all of our data drilling down to just 5 countries because there's way too many to obviously show all of our data on. Create our stacked bar chart here, and then we can of course drill down further and further in order to communicate what's important to us to our audience. And this is the power that ipyvizzu gives you. But I do see here that we are just at the end of our session today. There is a whole world of animated data stories that you can create with tools like Matplotlib and ipyvizzu. Instead of drawing attention to a series of static charts, you can embed context and truly guide your audience's attention from one chart or one scene to another with these data-linked transitions. I hope you can adopt these tools and tricks into the next narrative that you create to have your data story reach the broadest audience possible. And of course, I'm looking forward to seeing you all again next time.